yeah, thank you for attending my talk, and thank you for the introduction again. So aligned with the theme of this 20th anniversary event of OWASP, at Chusata just mentioned, my talk is about an ongoing research and also a proposal that also based on the past, but also look ahead to the long-term solution for security and privacy of the web. So let's review a little bit about the history of the web. So you know that the web started about 30 years ago, right? When it just started HTML, and then they have an application with the e-commerce and then social network, right? And the current trends in the web is AI service, AI-driven services, right? As you can see from this diagram. And by the way, I borrowed this from a Medium, an article from Fabric Ventures. No, but please just ignore the other stuff like Bitcoin and the other thing, right? So this is not focused on my talk, right? So I just want to point out that the state of the web, and also I want to point out here that we have an OWASP community here, like for the last 20 years, right? So let's review about the foundation of the web a little bit. I assume that everyone familiar with the web, but just ensure that we are on the same page in this. So the web, even like how many evolution or something happen in the future, the web technology right now is still based on the HTTP protocol, right? So where the web browser will send the request to the server, and then the server send the response to the client. So that is the basics. And nowadays the web contain a lot of other things, but the thing that the basic of the web is they have just the plain text with HTML, JavaScript, right, and also some CSS for the execution, right, execution in the browser. So nowadays, if you can see from the picture earlier, Web 3.0 have a lot of code running in the browser. It's kind of the edge computing, here is statistics. You may know that like JavaScript is now in every single web page, right? And that is the dominant programming language for the web, right? So let give you some example. Let me give you some example about the typical web page or website web application nowadays. So normally it's not only just the what you see. It's also have a lot of internal and external code running like behind the scene, right? And normally it's also include the third-party code. When, like, for example, your web page or your website include a code from somewhere else, normally you trust that code. And you include that, like the developer will include that. Like, I mean, here I call that by the host or the developer. So here I just show you an example that we see, like on the left-hand side, we see at the user, but on the right-hand side, you see there is the tool that I use in my browser. They display for like how many like external domain and the code that included by, you know, in this case, ebay.com. And there are also other tools that they know that they track, they know like how many tracker that track you during this visiting to the web, right? And these are, by the way, these are like popular the browser tool like uBlock Origin or Rosary or AdBlock, something like that, right? So so this is the general web application and the web in browser right now. So my research is about like security and the, like, you know, the concern and the privacy concern about the web right now for the user. So let's review about the, oh, by the way, there is a statistics earlier that like most of the top 10,000 website include like external web. That is a typical one that I just want to say, right? So so I want to review about some major security mechanisms in the browser for JavaScript code that because it's run in the browser. So JavaScript code download from the remote server normally, and then it's run inside the browser, right? On the fly. So the security, of course, must be guaranteed. And in this case, the execution will be in a sandbox environment. Of course, the code cannot direct access to your computer, and they have some limitation about the access to the computer. Otherwise, they can do whatever they want in the computer, right? That is one mechanism. The other mechanism, and it's well known in the web, is called same origin policy, right? So assume that because the browser open like too many websites like at the same time, and the user can visit different sites. So there are some confidentiality inside that site. And then the browser only keep for that website. So for example, you may know about cookie, right? So cookie is the sensitive information, and it's only share among the origin. Origin is stand for is formed by domain, protocol, and the port, right? So example here, like if you include or if you are in this domain, you cannot access the data of the other domain, right? So that is like one major security mechanism. And the other one later on was called content security policy. It's this additional layer to protect the attack. For example, one of the most popular attack is cross-site scripting attack, that the attacker can inject JavaScript code and execute JavaScript code, right? However, there are some limitation with this mechanism, right? So I give you a scenario where let's say the website, like for example, mysite.com, include the code from, let's say, ad.com, as I mentioned. So in this case, you see that when we include the code from external domain or remote domain, right? This code is a different domain. However, when it's included, it belongs to the same origin at the hosting page. Like in this case, will be mysite.com, right? So the issue here is that and this is this is still the limitation for this, is that when mysite.com include the code from ad.com, the mysite.com developer, or I mean in this case we call provider, always trust that ad.com will not harm or will not do maliciously in that mysite.com, of course, right? So it's this means that it's based on the trustworthy, right? So the provider will trust its partners that the code will be included, and then of course in that case the provider have to whitelist this third party, saying that okay, you are allowed to do this. But the issue here is that in the scenario, the code is not controlled by mysite.com in this scenario, right? So it's hosted like outside. It's hosted outside, and then in the, I mean, in reality, the code can be changed at any time, right? And seriously, like there's a case that the code hosted by outside can be compromised by attacker, not mysite.com, but ad.com, for example, right? So so in reality, that kind of attack like happen, right? So let me give you a real example that happened years ago. Like on the website you may know about, it's Reuters.com, right? So so a couple of years back, user of the Reuters.com experienced that when they visit an article, news, it's redirect the user to an attacker page like this. And it's happened in the past. So the common sense in this scenario, clearly that Reuters.com server who attack, right? I mean, that is the user of the Reuters. They you know, okay, something wrong happened on Reuters.com, right? But actually, it's not like that. Actually, Reuters.com had not been attacked, but Reuters.com website is attacked in this scenario by a code injection via the compromised ad network. So the attacker inject the code in the advertisement network. And in this case, you see the scenario I showed earlier, right? This is the kind of third-party JavaScript. And normally when we include like that, it's tested by the Reuters.com in this case, because this is a very common, you know, the revenue system, right? So so as the user, what do we concern about, right? At the user. So in this case, for example, like what we concern about. So what we worry about this. So Reuters.com example I showed you earlier is example of about security problem, but also similarity of that is the threat of privacy as well, right? So my research is to, you know, consider the like what the user will worry about and what user want for this. And the most importantly, I want to protect the user from, you know, this kind of threat and also the privacy leakage you may experience in the example of the eBay.com that I mentioned earlier, like user have been tracked, right? And related to this question, there's a lot of study out there. So for example, one of the studies said that a couple of studies said that the citizen maybe normally just the big tech to take care about their privacy, right? So they don't know like whether the privacy will be protected or not. And also we also have another study said that okay, we are not only just for example just block everything. They just want to receive some, you know, useful information, for example target ads, right? They don't not just block everything because that's useful to them. And recently there's a like design about like where we as the user we can have advanced method to control some, you know, the data that can be shared. So so these are the kind of, I said, the dilemma for the web user, right? So one hand, you want to have a like the protection, but the other hand, there will be the, you know, the way that they want to receive the information. For example, nowadays the AI driven in the web 3.0, right? So what are the solutions currently for this kind of scenario, right? So let me review some current approaches. So as I show you an example in the couple of slides back, there's a short-term approach. For example, the user can install the browser extension like Blocker, or maybe they have an in-browser blocking. For example, Brave browser nowadays they block things automatically, right? However, this was brought, as you can see, that it's still like on or no thing, like allow or just disallow everything. And I mean, this is about the advertisement and the tracking thing like that, right? So it's still not satisfied the dilemma that we just discussed, right? There are also more long-term mechanism. For example, you may hear about like do not track or privacy by design, or platform like it's called P3P, and also recently a lot of laws, you know, European law and US law, that they require the data should be protected for the user, right? However, um, um, these mechanism, it's just the the mechanism, but there's no way that to ensure that the mechanism can be uh, applied in the reality. And additional to this, there's more open challenge for that. Like for example, I mentioned to you about the same origin policy, right? The third party code can be malicious or can be compromised. And also there's no control from the user end to control their data to be shared or not to be shared. And most importantly, there's no formal insurance mechanism to guarantee about the if the agreement or the rule are enforced, right? So that is these are the challenges, the motivation for my work on code origin policy as broad, right? So I will discuss with you about the approach briefly. So my approach is on code origin policy, and the approach is to place the security reference monitor at runtime to mediate the security and privacy behavior, right? And it stay the novelty here is stay the origin of the caller of the API. So in that case, I call that term that term is the code origin, right? So in this approach, in my approach, the basic policy will be defined as agreement between the user and the provider, and normally it will be developed by the provider. So like the developer. So in this feature, you can see that the developer develop an app, and then they can include some JavaScript code, and then they can yield the code origin policy that I provide, customize that for this application particularly, and then it's included into the pay. So in that case, we have a product that we have the policy in check. The formal policy is not just agreement, right? And then where at runtime, it can be enforced by a reference monitor, right? So in that case, the browser can enforce that with runtime monitor, and the most importantly here is that it will be warranty with the formal method later on. I will show you that in the other slide. But the user, in this case, the user can also edit the policy like according to what they expect, right? So so I give you like a little bit more like it's not too deep the technical detail, but a little bit more about my approach here. So the idea is that like, in the regular execution, right, the API call will be executed in the JavaScript environment. And of course, there will be a stack to call that function, right? So our approach is that we put the reference monitor, and then we disconnect this call directly. We will wrap the call to our monitor, and then we have the policy, and we have a code origin policy there, right? So at runtime, we will also check the policy, and we check the call stack to know, okay, where the code come from, and then we execute the code accordingly, right? So I just give you some example of the code origin policy that we have. For example, we can define the policy that different origin have different access, different and different permission, right? And more than that, we can have a more fine-grained policy. For example, we can define that dynamic policy. For example, the bound policy limit the number of access, whitelist policy, history-based policy, and all of these are like based on the code of the origin. It means that where the code comes from, right? So I give you just the illustration about one prototype implementation we did. So it is the tool is called MyWeb. We published like years ago that we implement at the browser extension. and during the runtime, we count the stack, and then we get the origin of that, and then we apply the policy that based on the origin for the website. So a little bit more technical, I give you the example of the policy, how we enforce this. So for example, the next policy is we monitor the cookie access, and then we, so cookie access is the action, right? So we will see, okay, where the cookie, where the origin come from, and then we will check the policy if it's allowed or not allowed based on the idea of the code origin, where the code come from, and also the policy for that code, right? So some example we have earlier is the, just the basic information flow. We track the source, and then we track the sink. If there is the information leaked from source to sink, and then we can enforce the policies, and okay, we can do some automatically enforcement on that, and we prevent something that the information leakage can happen at runtime. In some case, we can ask the user because we may not know whether it's allowed or not, right? So that is part of the code origin policy enforcement. And as I mentioned earlier, the second part of my approach is that the formal insurance. So so for the formal insurance, and this is will be my long-term research vision as well. So in this vision, I anticipate that, and my mechanism will allow the code with the web would have a code origin policy, right? And then when the one that I showed you earlier, that is executed with the monitor, but there's no formal insurance, right? So my research now is try to ensure that when we have a code origin policy like this, we also have a tool to generate the formal proof that we call the certificate, right? So this certificate will be together with the code and also the policy, and at runtime it will be verified if the code already have the code origin policy, so that it's run the two things, right? The first thing is it can be monitored to ensure it's not violate the policy. The second thing is that they ensure that this code have this kind of enforcement at runtime. And so for now, we explore a couple of tools, and like for example, the current tool in informal methods, but we didn't have the final result yet. But we're still working on okay, how we generate this policy, and I mean the certificate, and how we verify this, right? So right, so in the team of my research, I just want we do for this anniversary event, right? So I just review about the related work, my work that related to the code origin policy I just mentioned to you. The way that I have is the lightweight shell protected in JavaScript that more than 10 years back, and I also presented in OWASP 2010. That is the basic idea for the how to monitor the behavior of the web. And then we also have a system that we apply the different policy for different origin. And recently I moved to the code origin policy that I just mentioned, and I also provide the mechanism for the user to modify the policy at runtime as well. And I just have a first prototype in code origin policy implement in the browser. So in the long-term vision, I just mentioned to you, the idea here is that we can have the code origin policy with kind of the formal privacy agreement is not just a test, but there are some formal way to define that in the code origin policy at the development phase. And then we will use the tool, we develop a tool to ensure that the certificate will be generated and will be verified at the runtime, right? So there's a lot of challenges here. For example, what type of policy are useful? We need to do the user study about this. Another way is, okay, how we input the regulation, the laws into this policy. And the most challenging thing that we are working on is like how to generate this and verify this to ensure the formal insurance, right? Okay, so yeah, so that is about my my talk. Just review back the web history again. So my hope is that we have question mark here that the code origin policy will be the future solution to provide the formal assurance for the security and privacy for the web and for the web user, right? So just 3 takeaway points. So of course, the current mechanism of the security is like not sufficient because they allow some attack and privacy concern. So we provide the approach on code origin policy, can have a fine-grained policy enforcement, and then this can empower the user to have more control on the data. And we work toward the formal insurance to ensure that we can have a formal proof that the policy enforcement can provide the protection and transparent without trustworthy. So yeah, thank you.